For problem number 13, we're asking about it being 1 to 1. So f of x, that function is given to you as x minus 3 squared. And that's just it. So if you look at what that graph is, this is why it's useful to know what the graphs are, what their parent functions look like, how we move things left to right. So this is going to be moved to the right by 3. And it's going to look like a U going up. I really don't have to draw more than that, because here's what I need to know. A one-to-one function, or an injective function, means that for every y value, and really the definition is like this, it says if f of a is equal to f of b, then that implies that a is equal to b. So what it means is that if your y value is the same, it came from the same x value. Let me give you an example. It says this. If this is, these are my x's and these are my y's, and obviously f is a function that does the mapping. Okay, so to go from x to y, I have this function f, and so for example, the number, let's not even think about this, but let's say I've got some value over here. Well, I'll use my a and my b values here. So if I have two different values that it maps you, let me use some numbers instead here. Let's say that, forget about this right up here. Let's say that 3, actually I only need one dot over here. Let's say that 3 maps over to 7. If a different number besides 3 also maps over to 7, so if 2 maps over to 7, so what this says is f of 2 is equal to 7, and f of 3 is equal to 7. So notice that f of 2 is equal to f of 3. That's what this guy right here is talking about. Now, if that's the case, if they're equal to each other, then a should be equal to b. So then 2 should be equal to 3, but it's not. So since it's not, this is not 1 to 1. It means that every y value comes from its own x value. So it means if I was going to go back, okay, if I was to work backward, I would know exactly where 7 came from. So if you told me f of something's equal to 7, I'd be able to tell you where it came from. Unfortunately, I can't here. I have to pick between 2 and 3. So if that occurs, then this is what we call not injective, okay, or not 1, 2, 1. Now let's look at the graph here. Here's what that means. If I've got the same y value, so let's just draw a line through there. These guys are both at the same height. Let's say they're both at the height of 1. Then that means they have to come from the same x value. But in this case, they don't. This x value is different than this x value. And so since we don't pass this test, which we call the horizontal line test, the function is not 1 to 1. Okay. Now, if a function's not 1 to 1, then when we go to graph its inverse, since it switches the x and the y, what's going to happen here is this guy is going to be turned on its side. Okay? And once it's turned on its side, the inverse, so therefore, the inverse fails. Since the original fails the horizontal, the inverse will fail the vertical. And since the inverse fails the vertical, the inverse is not a function. So that relation, there's still an inverse relation out there that exists, it's just not a function. Does it mean that f is a good choice for encryption? Absolutely not. Okay, because if we encrypt and we get a number out, we want to know exactly where it came from to decrypt, and we can't do that in this case. Okay, so in order to have a good encryption function, we need to make sure that that function is 1 to 1, so that it has an inverse, so that we can go ahead and decrypt.